All right, Assalamu alaikum. So, quickly reviewing on what we covered last time. This chapter mostly focuses on requirements, different types of requirements like functional, non-functional. We looked into user requirements, system requirements, and so on. So, what we covered last time was the functional and non-functional. Which of them focuses on what you expect the system to do? The functional, excellent. Which one focuses on how you do it? Non-functional. So here's the key now. Describing properties that would actually describe the behavior of your system. This is simply non-functional requirements. But when it comes to the actual features and use cases, this is mostly functional requirements. So when we are so picky about the button, how it will work, the navigation, how it will be done, this is entirely functional requirements. But when it comes to response time, let's say, non-functional. When it comes to security, when it comes to a standard to follow, non-functional. So all of them are considered non-functional requirements. Now SRS came in to turn these requirements into detailed copy that could be fully reliable on, can be shared among different people for the sake of better communication. And then we also looked into different techniques to gather these requirements from the user side, like surveys, interviews, study groups, and stuff like that. In that remaining part, we will focus on SRS document, specification, requirements, validation. And that's the last part, actually, of this chapter. All right, who can start by reading this? Yes.
Requirement elicitation. Challenges of requirement elicitation. As an analyst, I need to know what do you want. I want you to design the software for me. But what do you want to do with the software? I don't know until you tell me what the software can do. Well, I can't design the software to do anything. Can you design the software to tell you my requirements?
Okay, so we talked about this before, right? So when the customer or end user doesn't know how to explain requirements, right? Then you need to offer a lot of possible formats to make sure that there is a good communication with that end user for you to ensure that it's ready to move to design and implementation stage, right? So we're not talking here about the elicitation techniques. We're not talking about how would you extract these details. But how would you write requirements in a way that makes it a full mapping to what the customer or stakeholder actually expect? All right. So came in the requirement specification to do that purpose, okay? So imagine you're having a system, and by system, I'm not focusing on software aspect. I can split my system into a software side and a hardware side, yes? Then comes in that bridge in between, which is simply, okay. That bridge is what helps you avoid any miscommunication between the software components and the hardware components, okay? So, there are one of two approaches. When you provide a full guidance on how a process is simply followed, and then people would just follow it as described. And the other way to do it is when you have no specification, and then you leave it for everyone the imagination. And in that case, you're not necessarily reaching the final exact output you're expecting. So specification came in to unify our own expectations. Us as a team, designer, developers, testing people, and also customers, stakeholders, investors, and so on. So it's a unified document that's viewed by everyone. All right, so last time we talked about functional, non-functional requirements. And we said this has to be detailed, it has to be clear, it doesn't have to be ambiguous, right? Then how can we clear any misconception about it? We simply look into specification cards. Consider each of these functional requirements, and let's consider a use case. Hello. Now every use case will be mapped here into a full card. This card has the name that holds the title of this functional requirement or non-functional requirement, but the focus here again is functional. Precondition and postcondition. Let's think of some scenarios. All right, is it the case that you just enter the URL and you're able to upload a file on Moodle? What happens before you upload something on Moodle? Is there any precondition?
Sometimes you have to log in again.
Log in, so that's a precondition. What else?
The size. Checks the size.
Checks the size, excellent. So the size of that document has to be within whatever is allowed.
The format also.
And the format could be PDF only, or let's say Excel only, and so on. Excellent.
Might ask you to go like to the place to submit. And
Perfect.
it might be in the same week, for example, and then you go to the.
Excellent. So you need to choose the right feature. Very good. Excellent. Okay, back to your point, when you check, let's say, the format, is that before or after?
After.
When the system actually does the check? It's after. So when you click submit, yeah? It goes for these checks. So there are preconditions. I have to be logged in. I have to be, let's say, a student role, yeah? And the post condition in that case could be, for example, the file is the right format, right size, within the time that's specified, and so on. So these are post conditions. So we look into the description, precondition, post condition. Who's the key actor? Who's the key actor? So the user who's going to be activating this feature. So in that case, it could be either student, faculty, admin, anyone who can use the system, but only limited to this feature here. Now, let's elaborate more. So again, still, the end user is not happy. He's saying still vague. So the main scenario now is provided in terms of key steps. We provide step 1, 2, 3, 4. What happens in sequence? So user insert, let's say, a card. If this is an ATM machine, insert a card, ask for password, enter your password, a validation happen. We can still map this to any software, right? Okay, that's the ideal situation. What if something happened? You said the time of this activity could be over, it's due. That's one scenario, right? That's one branch, okay? Another branch, the size is exceeding what's required. Another scenario, yeah? The format of that file is not supported, a third branch. So now we start looking into extensions of these scenarios. And we call this branching actions. So what could happen here? So a notification might be sent to the user, maybe an alert message, yeah? And then you ask it, let's say, to fix the file, or let's say contact your supervisor to extend the time. So this is simply one card that would map to each use case we put in the functional requirements. Make sense? Again, this is just a template. But of course, now you can imagine how many pages just a requirement document might have for this part only. If we're having 20 use cases, remember this diagram? Now each of them now would be turned into a full card. Now the nice part about the precondition and postcondition is showing the dependencies. Sometimes this use case is dependent fully on another use case, yeah? So again, I cannot proceed to payment unless I'm logged in, yeah? So the precondition has to be login, which is another functional requirement in that case. So here we start seeing the dependency of these requirements, whether it's a start to end, or end to start, or end to end, or start to start, as we explained before. Okay, you don't need to memorize any of this, okay? Let me just clarify. So we talked about different ways of speaking to the end user. Let us just categorize these possible techniques. So in most of the cases, you will see that the SRS are simply written in simple text, like this. You can specify what happens if certain button, let's say, is pressed. And this is the most commonly used. Another technique that used to be in action, but no longer, or very minimal, you will see it, we call it requirement sentence template. Here, you turn this text here into possible blocks. So you try to see what's in between that block, what's the key action, Okay? So here, if button 4 is not down, this is a condition, right? What's going to be the action? Within 5 seconds. So this is my time constraint. So you just keep on highlighting whatever variables or constraints that might control the whole scenario. Third technique is when you try to elaborate on any use case with a representation of equations. Okay? So sometimes you need to explain to the end user how the system will carry out the calculation behind. Okay? It doesn't have to be fully detailed because not all the users of that document will actually fully understand the concept. Yeah? But sometimes you can present the whole idea with equations. And again, keep in mind, what's P1, T1, P2, P3? See that? So these are the variables you specified in that scenario. Again, these two, I wouldn't say they are heavily used. I would say rarely used. Like we never see them in SRS, the modern ones at least nowadays. Yes, please.
Doctor, are these equations probabilities?
Could be probabilities, yes. So yeah, it's actually holding some probability at certain point, but again, depending on how many of these actions or conditions can be merged at a time. You know the simple stands for what? What?
Power.
Intersect. So there is intersect, possibly union, possibly, I don't know, like, that's, or, yeah, so I have no idea what is that exactly, okay? But I'm assuming it's related to these variables on the left side. Again, this is not very common to see, honestly. But it used to be part of the collection of requirements. Like,
Okay, this
it
one is
used
like-
to be represented somehow.
This one is like scratch.
That's like Scratch. You see it like Scratch, yes. But again, highlighting the key actions and key conditions. Okay? Now the last one here is the graphical representation, and again, this is quite common. Sorry, this is quite common still. So here we turn the whole scenario into a nice graph that's easy to visualize. We'll see some samples now on this. So there are some good tips that can help us make sure that our requirements are written in the best way possible. We talked about using a standard before, remember? So we said this can be ISO standard, IEEE standard, vehicle safety standard, just anything that's related to the context of your software. Make sure your stakeholder understand what you are writing. Yeah? And make sure you understand their own needs. So there should be a good communication between stakeholders and the entire team. And understanding requirements is the key to ensure later stages are actually taken care of. Use proper grammar. So use here proper grammar. So not so ideal to see, let's say, some grammatical mistakes, typos, or let's say things that are miswritten while providing this as a formal documentation. Ensure traceability. So I think this is the most important of all. When we ensure that this use case is traceable, it means we can test it. Yeah, we can know its own origin, like from where this requirement came. Of course, you add it in the right format in terms of name, number, description, as we've seen in the previous cards. Don't provide instructions. I'm not here to tell you how to use it, this requirement, or how to navigate, let's say, on the system, let's say, to find it. That's not the issue. It's not a tutorial. It's not a manual, okay? What you provide is simple steps of how to implement, okay? Not how to find or how to reach. All right, of course, being specific, understanding what's needed. So we talked about graphical representation in the previous stage. That's one sample. We call it use case diagram. And here you simply end up with a representation of actors active in the scene, like doctor, nurse, let's say medical receptionist, manager, and so on. Then we try to link each of these actors to the set of use cases they are simply interacting with. So the person here, for example, the medical receptionist, they can register the patient. They can view the personal info. While nurse, let's say, and doctor, they both can view the record of given patient. They can edit the record even. The doctor can set up a consultation. Yeah? So you might see that some of these use cases could be common among multiple actors, or it can be simply linked to another use case. So I can have one use case that's linked, let's say, to another use case, which in that case detects there is a level of dependency. And then later we can specify the level of dependency, whether it's again start to end to start, and so on. On the right side, that's another way of visualizing requirements. So we dealt with the prototype at the early stage, if you remember, in the earlier chapters. Now it's time to turn this prototype into testable component, yeah? So what happens when this, let's say, when this option is chosen? What happens when this option is chosen, and so on. So now you can show it in a flow chart. So this helps, and by the way, all what you use here is simple, sticky notes, paper-based work, but again, showing the overall flow of the entire system. Now that's a typical SRS template that could be used to build your SRS document, but again, we don't have to stick fully to it. In most of the practices, you will see these documents get to be restructured differently. Again, depending on the business vision, the system type, and lots of other factors. But the most common, let's focus on that. So for example, I'm expecting introduction with the purpose of this document, the entire scope of the project, and some references if applicable. Let's look into the key part here. We have overall description. From the product perspective, we can have user classes and characteristics. So who are you targeting? Remember when we said there is a target user? This target user has sometimes a specific age, a specific gender, yeah? They could be children, adults, teenagers. So you need to specify who are the target group you are, who are part of your own system requirements. What's the operating environment? So this system, is it only applicable to work, let's say, in over cloud? Is it supported, let's say, on operating systems like Linux, Windows? Is it like an iOS application, or Android and iOS, and so on? So the operating environment has to be clearly defined. Sometimes it's just a physical environment. You just need to explain how these servers are working, how these computers, let's say, are acting, and so on. And if there is any constraint when it comes to design and implementation. So this can be something unified, let's say, on resources, on tools, yeah, on the timeline, let's say, of the project. Any possible constraints related has to be listed. And assumptions and dependencies need to be also reflected. Assumptions in the term of, I'm assuming that this is the preset scenario, yeah, before anything else happens. Now dependencies mean I try to identify the relation between these use cases or functional requirements. Now system feature is what focuses on functional requirements the most. So here you can add the list of functional requirements as we mentioned. You can provide the WBS or the work breakdown structure of these requirements, followed by detailed cards, which we call card specification. Okay, so we can also look into data dictionary here, which is again a very important terminology. What's data dictionary? So sometimes we're using some key terminologies that are not clear, okay? We just need to clarify this. So what do we mean by this word when it's used later on in our SRS document? So this dictionary helps you clear any doubts. If anyone read this document, whether they have technical or non-technical background, they can actually stay with the same, with you on the same page. Same for data acquisition, integrity, retention, and disposal. So how would you create these data in first place? Sometimes, even after the system is delivered, there should be a strategy of getting rid of these data. Not all of the data has to be kept. So how would you get rid of this? All right. Now we need to look into the external interface requirements. So we have here user interface, software interface, hardware interface, and communication interface. Let's agree on this. So we have users, as we explained before, requirements could be user related and can be also system related, yes? So when we say user, it means anything that's very specific to you as a user. Let's say you are a manager, or let's say a college dean. You need to view, let's say, certain reports, yeah? So this is a very exclusive feature supported by the system, given only to your user category. So we call this a user requirement. Okay, now we have software interface, hardware interface. Now let's look into the system itself. Is it entirely software? And if that's the case, we need to look into the key functional, non-functional requirements below it. Same for the hardware requirements. So look into the sensors, the cameras, look into specification of them, look into whether they map to your own case study or not. Yeah? So this comes here. Now the communication between this interface component is also important. So getting to, thank you, you're so sweet, thank you. So the communication between these two components is also important. So how the network communication actually takes place. Thank you. So connection, let's say over network, when it comes, let's say, to cloud-based transactions or contacting back-end databases. In many cases, you will see that you can design a very nice diagram. We call it, let me show you. How about this? And then I can stop afterwards. We can have,
Doctor,
please.
what did you say the communication interface was?
So communication works mostly for network level. So over, let's say, is this communication happening over Wi-Fi, for example? Is it Bluetooth based? Yeah. So this is mostly for the network. You can, or Ethernet it could be. You can talk about the communication with the back-end database. Let me show you something nice. Yeah, okay, this is one example. Could be nice. Okay, do you see that picture here? Okay, so here we have workstation, a simple PC, a modem, and then a public telephone network, another modem, and then a server. So here I can show how these components, hardware side, communicate with each other through the modem, yeah? When it's the hardware specification, I only talk about the workstation alone. I talk about the server alone, yeah? So how would these be featured? But then communication will look into these links in between. So how this can communicate with this, how this can communicate with this, okay? In modern world, this is gonna be simply Wi-Fi, Bluetooth, things that can help devices actually transmit data easily in between, okay?
What
Please.
about when hardware needs to communicate with the software? Is it the same?
When the hardware communicates with the software,
Like,
how
for
is that
example,
happening?
if you have sensors and you need to send it or signal it.
Nice, very good. So here we talk about database. Database could be hosted on the cloud. So it's a place where you just push your data in, okay? Like a storage. Let's call it a storage. So you have this medium, you have this, the software side, you have the hardware side, this one, the hardware side, okay, and a cloud in between. This cloud could be simply a database storage. So again, how this software usually, let's start with the sensors. These sensors, let's say, are extracting data from real world, okay? So you're capturing, let's say, some data on temperature. So these are simply sent directly to the data set on the cloud, yes? Now, the application that runs on the hardware, that could be a phone or laptop, request an access to these information. So it gets access to whatever records are needed, and it displays it to you on the screen. So communication between this layer and this layer, simply over internet, okay? So this can simply use Wi-Fi. This and this can use Bluetooth. If the sensors and the data storage, let's say, are well synchronized on the same network. So again, the communication is different, like it depends on the types of devices, types of sensors mostly, and the limitations, I would say, of the hardware you are using, but most of them will be around that infrastructure, okay? Oh, that's a good example. See that? For example, a car, a house, and a device. That's a radio network. Okay, now that's not clear. That's a good one. See this, you have a satellite, cellular, let's say, service, you have internet, you have remote offices, you have ambulance, and then it shows you how these communicate. So this is the layer of communication, okay? It could be satellite-based, could be modems, could be Wi-Fi, could be any possible routers that you can use. Okay? And of course, we look into quality attributes, which is a simple non-functional requirement summary on usability, performance, security, safety, interoperability, all of these, okay? If you want to talk about internationalization or localization, so sometimes your application is supporting English, French, Chinese, yeah? That's localization. Internationalization. If you want to look into Arabic, let's say specifically, this can be offered in multiple accents. So I can look, for example, into the Egyptian accent, the Saudi accent, yeah? What else? The Jordanian accent, yeah? So these are all different localization requirements. If there is anything that wasn't listed here up, you can simply add it in a separate section, and of course you can add any possible glossary or appendix files that could be even external documents taken from the company, let's say, or whoever requested the service. Okay, I'll stop it here today. We're only like four slides left on that chapter to end. Then we start, inshallah, a new chapter. But I promised you to end it. But I just want to take 1 minute, okay? Just 1 minute. I posted the assignments for everyone yesterday on SE201. It has 3 problems. So first one is on requirements elicitation. So here you're expecting to pick any system idea, go for one of these 2 techniques, either a survey or interviews, and this is the minimum benchmark you need to get. If it's an interview, try to interview 5 key stakeholders of your system. If it's a survey, just fill it with 15 participants, okay? Again, pick an easy idea that you can reach people for. Once you have this data collected, try to extract your functional, non-functional requirements from them, okay? And try to look for any 2 ambiguous requirements, things that were not clear to you or were contradicting. Then try to turn it into a clearly written one, like properly formatted. Then describe which process model you will use to implement the system with some simple justification. That's the first problem. Second problem, Question 2 is mostly focusing on prototype presentation. So here, this is a physical prototype. I told you, you will be preparing something physical for that first assignment. So we expect a physical mock-up or a model for hardware, software system of your choice. You can design it using foam, you can design it using Legos, paper paste, if you want any available material. Any available material. Don't overcomplicate things, but make sure you can deliver something that's easy to explain, okay? Then you are asked to provide a simple demo or a 2 to 3 clear pictures. Okay? Now, last question. So here I'm expecting you to work in pairs on this question. That's a case study, and I'm not here to judge your level of skills on programming, but this is a very interesting case study, okay? I know you all started with Python in SE100, and I remember first week, a lot of guys requested having some coding problems as we move on. I think this one example can give you a lot of practice. What you've seen on Python so far is simply basics, but I want you to try to link it into real case study problems. So let's start with a simple practice on image processing. I know you have nothing to do with image processing, okay? But let's assume, okay, I'll tell you, huma 3 easy scenarios, I'll tell you. And by the way, the entire code I'm expecting is 15 to 20 line of codes, nothing. Literally nothing, but you will need to use a new library, we call it OpenCV. You know OpenCV library? No? Then search it, okay? Again, you can consult even ChatGPT on, it's okay. I don't mind. The coding is okay with me. But I want you to follow the technique of pair programming here. So the key 3 case studies that I need you to solve, bring any picture, okay? I need you to try to increase its own brightness by 20%. Try to make a contrast for it by 40%. Try to resize it by 50%, width and height. So zoom in or zoom out, okay? These are the 3 possible scenarios. We call this image enhancement, okay? Scenario-wise, it's very simple, and the coding itself, even behind, is very simple. But I want you to start from there, okay? So work with this, with the concept of pair programming. One of you will work as a navigator, and the other will be the driver. Then you will keep on swapping every 5 minutes. I'm sure it won't take even 15 to 20 minutes from you, okay? It's really short piece of code. So if it's, let's say, 20 lines, then let it be 5 minutes, okay? You split the time. So at the very end, I need a log from your side. Just tell me which time, who was the navigator, who was the driver. Then when did the swap happen?